Alright, so here in lesson 62, we're going to continue working through some of these where we are going to be using the natural log, the u prime over u, to integrate. But there's a couple little twists that we need to work with, and then we'll also look at solving a differential equation. Okay? So we have, first of all, an example of one. Oh, I always do that. An example of one here where we need to find the integral of this rational function, but we don't have u prime over u. It's not a monomial in the bottom, so I can't split it up into separate fractions that way and reduce them. It is not something that I can use u substitution for. So how do we handle this? Well, this is a case where we can split this up into multiple parts, but we have to do it using polynomial long division. Okay? So just as a matter of review, if we're trying to divide x squared plus x plus 1 by x squared plus 1, remember, we just look at the first terms of our dividend and our divisor, these two parts. So x squared divided by x squared is just 1. Now, I like to help myself out by putting things over things that match, like terms. So since I have just a 1, it's a constant, it's going over the constant part. Now when I multiply, I have an x squared and a plus 1. Which I then have to subtract. And notice what I have left is an x, and that's it. Okay? Now, the nice thing about this, there's a couple of ways that you can help yourself understand when you're done and just need to write your remainder. The easiest way is look at what you have down here. It's just x to the first power. That's a lower power than what you're dividing by. So, since it's a smaller power than this, I know I can simply write my remainder now as x over x squared plus 1. Okay? So there is our polynomial long division, and when I'm trying to find this integral, I can now make this the integral of 1 dx plus the integral of x over x squared plus 1 dx. Okay? Yes, Davi?
So you divide the biggest one by the other one?
Yeah, I don't even bother looking at the plus 1 here or the plus x and the plus 1. I just look at the first term and the first term. How does that divide? X squared divided by x squared is 1. And then I'll multiply through everything else. And subtract and bring down if I need to.
Shouldn't you also have a 1 over x squared plus 1?
No. Because this was 1 and then I subtracted 1, so it's 0. So now we have something that we're able to integrate. The integral of 1 is what?
0.
That's a derivative. Integral is
X.
x.
Snickerdoodle, yeah.
Oh. So that's x plus, now we've got to do the integral of x over x squared plus 1. So again, I see a rational function. It's not a monomial on the bottom, so I'm thinking, okay, do I have a u prime over u?
Yes.
Pretty close, right? I just need a 2. So that means I have to put a 1/2 outside. And now the integral is going to equal what?
1/2 plus 1/2 times ln absolute value x squared plus 1 plus absolute value plus 6.
There you go, good. Okay? Once I see I have a u prime over u, that'll work. And by the way, guys, think about this. This should always work, because when do we stop? we stop once we get a power that's just below the power we're dividing by. Well, when I take a derivative, the derivative has a power that's 1 less than the one I'm dividing by, or the one I started with, okay? So it kind of sets us up nicely to use this u prime over u, okay? So here's a couple. Don't forget, like on number 1, don't forget that if you just have x to the first power, you don't have to do polynomial long division. What can you do?
Synthetic division.
Yeah, you can do synthetic division. Do we remember how to do that?
No.
Been a while? Okay. That's okay. So I have that x cubed plus 0x squared minus 6x minus 20. So I'm just going to put the coefficients, 1x cubed, 0x squared, minus 6, minus 20.
What is this?
This is synthetic division. We did this last year in pre-calc honors, probably around Thanksgiving time. So it's been a while. It's not too hard once you get the pattern. If you can't remember this, we can do long division still. It's not that you can't, it's just this is a little faster if you know how to do it. So I have the coefficients of the numerator. I'm dividing by x plus 5.
So it's a negative 5.
So I put a negative 5 here, that's right. And then remember, you add down, 1 plus 0 is 1, and you multiply over. 1 times negative 5 is negative 5. Add down, times negative 5 is 25. Add down, and you get 19. Times a negative 5 is a negative 95. Add down and you get a negative 115. Okay?
Where'd you get that 6 from?
Oh, 5 times
The
five
negative
is
6
25.
here?
No, the other one.
There is no negative, there is no other 6.
Oh, it's an arrow.
Oh yeah, these are arrows.
Okay. Oh, I thought the one on the left was.
No. Oh no, that's just an arrow straight down. Okay, so how does this help us? Well, let's look at what that actually gives us, alright? I can now rewrite this integral as the integral of, I started with x cubed, so that means this is an x squared, x, a constant, and then this is the remainder, okay? This is our remainder. So that means I've got x squared minus 5x plus 19 minus 115 over x plus 5. Okay?
Mr. Nixon,
Yes.
if I know long division, would you advise me to learn synthetic? Like,
Well, this was a whole lot faster than long division.
yeah,
So-
but I mean, on the test, would it really make a difference? Like,
That's
if-
up to you. It's up to you. You got a number of tools available.
We have limited time.
You know, you have a limited amount of time, so the more efficiently you can work, the better. This is a simpler process than doing the long division, so you're less likely to make a mistake. But the key is it only works if you have x to the first power with the constant.
Oh, it has to be X.
Yeah, it's got to be with the x to the first power.
What if it doesn't have a constant?
Then, if it's just an x, then that's a monomial, so you're going to split this into 3 separate fractions and divide that way. Okay? Yeah, Chloe?
Yeah, why is that negative 5?
Because in synthetic division, this whole process is designed for when you're dividing by what they say is x minus a constant. So since it calls for us to be dividing by x minus a constant, we have an x plus 5, we have to think of that as x minus a negative 5. So that's why we use the negative 5 down here. Okay? Alright, now if you guys need a little more help with the synthetic division, I can help you with that later. But let's go ahead and finish off our integral here. This is going to be x cubed over 3 minus 5x squared over 2 plus 19x minus, and then what's going to be the integral of 115 over x plus 5?
115 times I times x plus 5.
Okay, 115 times the ln of the absolute value of what?
X plus 5.
X plus 5. The derivative of x plus 5 is just a 1. So we could see that as 115 times 1 over x plus 5. So there you have the u prime over u. Okay? And then don't forget the plus c here at the end. Okay?
Mr. Gibson, numbers 2 and 4 are the same. It's the same problem.
No, one's minus one, one's
Oh,
plus
it's
one.
minus 1.
There's a little difference there, okay?
Plus is different than minus.
Alright, so I'm going to give you a couple of minutes here to try 2, 3, and 4. Alright? Hang off on number 5 for a sec. If everyone gets done, then we'll just go ahead and start. But I'm going to give you a couple of minutes to try a few of these, and then we'll go over them here. Alright, here. We're getting a little bit stuck on the second one. Alright, did anyone get a solution they thought would work? I saw Winnie had a solution that was working. Anyone else? Okay. Alright, Winnie, how about if you share with us how you handled number 2 here?
So x plus 1 equal to u, and then we can find the derivative of u is 1x. But then on the numerator,
Wait, the derivative of u du is, okay, 1.
yeah.
Gentlemen, please listen. Okay, so 1 dx.
Yes, so I was thinking about like using the method we learned like last week. So it's like, so using, it just like substitute everything to u. But then like x, like on the numerator, it can be expressed as u minus 1.
Okay, good. X would equal u minus 1. And what that does, like she said, now we can substitute everything out to u's. Okay? So we've got the integral of 2 times u minus 1 over a u squared du. Okay?
Then you like open the parentheses, then you do like you separate them to subtract.
Yeah, we've got a 2u over u squared minus a 2 over u squared. Okay, and now we've got something that we can take the integral of, because that u here will cancel out the u there. And now it's just the integral of 2 over u. What's the integral of 2 over u?
Negative 2 over u squared.
No.
This here?
2 times
Oh, 2.
Yeah, we just learned it. 2 ln of absolute value of u. Remember, because the power rule doesn't work if it's to the negative 1 power. Okay? And then what's the integral of 2 over u squared?
2 ln of u squared.
No.
No, it's just ln of ln.
There's no ln
is
here.
squared.
Oh, it's like
There's no ln here. It's not negative 1, right?
you do the negative 2, then you just do the integral of that.
Okay, it's minus 2u to the negative 2, and now we can use the power rule. Alright?
Oh, okay. But can you use the ln over?
No,
When?
because it's not 1 over x or 1 over u.
It can't be 1
It's
over x.
only when it's to the first power there. Okay? So, if we have that, we add 1 to the exponent, so now it's to the negative 1 power. We multiply or divide by negative 1, and that's going to make it a plus 2 u to the negative 1. Now, were we asked for the integral with respect to u?
Yes, I'm sorry, you lost me there. I did consider you the negative one.
This is a minus 2 u to the negative 2. So add 1 to the exponent, divide by the new exponent. Just like x squared is x cubed over 3.
Oh, okay. Oh, okay.
It's, you add 1, so it's x to the negative 1, or u to the negative 1, divided by negative 1.
Gotcha. So like what you did is you put the u squared up top and made it a negative. You made it a u to the negative 2.
Yes.
Integrated.
Yes.
Okay.
Okay? So the only thing left to do here is we need to make sure we give our answer in terms of x, because we were told to find the integral with respect to x. Okay? So we're just plugging it back in. U is x plus 1, so our final answer, 2 ln absolute value of x plus 1 plus 2 over x plus 1. Okay? Does that make better sense? Okay. Now you guys were using some good ideas. Some of you tried to FOIL the bottom and see if you had a u prime over u, and we were missing part of it and there wasn't any way to get it. Okay, so that was a good thought, but the reason why we're giving you these is you can't forget about things that you've learned how to do in the past. Just the straight u substitution. This is the stuff we were doing last week. So don't just automatically assume that since we're in a section where we're using u prime over u, that every problem is going to be that way, okay? Get used to kind of running through the checklist in your head of different methods that you can use for integration, okay? All right, yes?
Peter pointed out that there should be plus c.
Yes, there should be a plus c. Thank you. There should be a plus c. Okay. Now think we can tackle 3 and 4? You guys can tackle 3 and 4? That one was a little tough because it made us kind of think back a little bit. So now we want to solve the differential equation dy dx equals 1 over x ln of x. Now, what do they mean by solve it? We want to solve it for y. Find y. Okay?
So they want to find the
So, if I want to find y, here's what we're going to do, all right? In this process, you'll do basically every time you've got one of these. First thing I'm going to do is I'm going to get y's on one side, and I'm going to get everything else, the x's on the other side. So I'm actually going to multiply both sides by dx. Okay? So I've got dy equals 1 over x ln of x dx. Okay? Now, I'm going to take the integral of both sides. Well, this is just a 1 dy. What's the integral of 1 dy? Y. Okay?
Yeah.
Now, this other one is a little bit tricky to see how we would integrate. Okay, the right-hand side. Let me rewrite this a little bit.
I think I got it.
What do you think?
Well, I think the 1 over x is the ln of x, but then since it's the 1 over ln of x, would it just be x? So then is it x over x, which is 1?
Not quite. Let's split this up a little bit. 1 over x times 1 over ln of x. Okay? And let's say I multiplied this a little bit different way when I wrote the answer down. When I multiplied, I could write this as 1 over x over ln of x, right? So u equals ln x. What's u prime? It's 1 over x. So guess what? I have u prime over u what's the integral of u prime over u?
That's so weird though.
Yeah,
I thought it was.
it's
How
not
are we
the
going to
same.
see
The
that?
last
All right.
Before the quiz, the hardest one.
Wait,
So
how
it's-
are we going to see that, like, if we move 1 over x to the top, it will be u and
So you
How
just
are we-
have.
How do you see that? Just practice. You just try some. Okay. So this is going to be natural log of u. Well, u was the natural log of x, right?
Is this like a common question?
Huh?
Is this like a sort of common question?
Well, as far as having to rewrite it the way we did, maybe not, but it is, I mean, this type of thing, solving the differential equation, does show up quite a bit. Okay?
Oh wait, so are you saying that this is the integral of the natural log of u prime over u, and this is the integral of u prime over u, and it's the natural log?
Yes. So notice here, guys, our answer, if we're taking the integral of u prime over u, it ends up being the natural log of u. Okay? Well, we've got u prime over u over u, so that's the natural log of u.
But is it like absolute to you?
Wow, love that.
Yeah. Yeah, absolute value here. Okay? So that's why we have the natural log of the absolute value of the natural log of x.
Can you take the integral of ln x or?
The integral of ln of x?
Yeah.
I think there's a rule for that somewhere, but okay. But this would just be our final answer here. Okay, ln of the absolute value of ln of x.
I think keep all that bracket.
Okay, what's that?
How derivative of the I ln x equals to the 1 over x.
That was one of the rules that we had learned based on our definition of the natural log was the integral from 1 to x of 1 over t dt. That was ln of x. So then if we took the derivative of both sides, we had the second fundamental theorem of calculus. Hey guys, shh. We had the second fundamental theorem of calculus says that this right hand side would just equal 1 over x. And this is the derivative of ln of x.
So whatever ln and a number, whatever ln times a number, then its derivative is 1 over that number. Can I look at that way?
Wait. If it's
I mean, if ln times any number, then its the derivative is equal to 1 over that number.
well, actually no, because if it's ln of a number, that's a constant, so the derivative would equal 0.
So if it's x, then it will be like that.
Yes.
I just need to remember the ins, its derivative is 1 over.
Yeah, that's just a rule you should
What about
memorize.
in